So since my computer came with the RAM expansion installed already, and I have all these boards here laying around, I'm going to try and take the memory upgrade in here out and see if I can get some of these memory boards to work properly. And I guess the goal is just to fill the last 120 or 256K of memory to make this computer up to 640K, just using these boards instead of the specific memory upgrades for this machine, just to see if it's possible, because these things are way cheaper online than the actual upgrades for these things. So like this I got for like, well, yeah, this one I got for probably 10 bucks, maybe 10 bucks for that. Basically all just about 10 bucks, except for this one. This one came with the computer, and apparently they wanted EMS inside this thing. So I don't even know. I guess that would work if you have the right one. I don't know. I've never seen people try using like EMS on like 16-bit computers, because usually you don't really even need anything more than 640K, at least for the programs that would run on a computer like this. Since my last video, though, I did get a replacement floppy disk drive for this one. Actually, two of them. It is actually about the same price to buy a whole other computer than it was to buy like the individual drives. Like two floppy disk drives, they want like $60 to $80 on Yahoo auctions, and one drive is like $30 to $40. And I bought another broken unit for $15. Of course, the shipping is a lot higher, but between the price of the actual item, the shipping changing, it kind of equaled out. So why the heck not just get a whole other unit? So I did that instead. Except it's already gone. I shipped it off. I'm going to give it to somebody who can figure out how to make some circuit boards for the VFO, so I could use a GoTech eventually. So I send them a computer, and I get some circuit boards back. At least that's the idea. So anyway, let's remove those boards. So these are the memory boards that come with the UV, or they don't come with the UV, but they can be used to expand the UV. So wiggle them out. 128K of memory for each. So if I remove these, it will drop the memory down to the base value for this machine, which is 384K of memory just right here. And yeah, it will be complaining pretty loudly when it realizes that its memory setting is wrong. At least I think it will. So the first board I'm going to try is this one here. This is a PC-9801-2 board from NEC, and this was designed for the older PC-9801 machines, such as the M and F series, and I think the first version of the PC-9801. And it's designed for computers that are 8 megahertz or slower, so this may not actually work on this computer. This is the least likely to work, actually, because this computer runs at 10 megahertz, even though it's switchable to 8 if I wanted to, but why would I want to do that? So let's throw this in here. I'm probably going to put the case on here and run it, because this is from the era of explodey tantalum capacitors. So I'm going to make sure it doesn't blow up in my face. Well, maybe I should have it open so I can see if it smokes. I don't know. Let me actually get this in here correctly. Okay, now we have our memory installed. I'm going to leave the CMOS or the BIOS settings intact, because it's already set 640K, so I'm going to see if it automatically just goes to 640K. And we'll be going to use DOS to test the amount of memory, and also just to test a game to see how fast it fails, at least this board here. We're going to be running Puyo Puyo, because that one is a little bit picky with its memory. So I'm going to be lazy and not use my capture device, because that's a little bit too much fiddling around when I'm swapping hardware in and out. It's not really about the gameplay footage. We'll just do this instead. Fire in the hole. If it goes pop, I got the button to shut it off right here. Okay, it's not happy with that. They don't like that memory board, it looks like. Let me see if it will boot into BASIC. Let's see here. Oh, yeah. Okay, so it thinks it's 384K again. Let's boot up. Actually, what we can do, let me grab a screwdriver and flip the dip switch for the the memory switch settings, have it reset that. Hit the reset button here. So now it should load defaults when it starts the computer. And so for one, BASIC's not going to crash anymore because when I turn on the sound card, for whatever reason, BASIC crashes. Alright, so BASIC's there. Yeah, okay. Okay, so now it should be at 640K setting again. Might complain. Oh shoot, I forgot. I forgot to reset my switch to keep settings instead of resetting them every time it turns the computer off. Alright, now we will try to boot it. Yep, it's not very happy. At least this computer will give out beep codes if it has something that goes wrong inside of it. So we're probably not going to see our full 640K with this memory board in here. It's probably not very happy about that. Yeah, it's not happy. So let's try... Let's run it at 8 megahertz. If I flip the switch, it's very difficult to move. We switch it to 8 megahertz. And it's still not very happy. Alright, so this board obviously doesn't want to work very well. Let's turn it back to 10 megahertz, and I'm going to say that this memory board does not function correctly in the 9801UV. It requires something a little bit older. At least none of the tantalum capacitors blew up, though. It's kind of neat to have around, I suppose. It's just a circuit board. The second memory board I'm going to try is going to be more likely to succeed. This is a Melco BM1000. What this is bank memory. So the way this functions is not like EMS or anything like that. This is bank memory. So what you do is that you use the memory in this board to fill out the last bit of your conventional memory if you can't. So that's actually a function this thing provides. And what you do to access the rest of the memory on here, I think this has 1 megabyte of memory on it. But what it does is it bank switches in the conventional memory. So what you have to do is set the dip switches on the computer to run with 512 kilobytes instead of 640K for conventional memory. And this board, using the software that it comes with, which I don't have, it will swap out the last 128K between all the different banks in here, giving you your full 1 megabyte. And I'm guessing that's really slow, but it seems to have been pretty popular with the early 9801 machines, sort of like the one that I have here. So first of all, we're going to need to figure out what the dip switches do. So luckily, or actually not luckily, my favorite site for PC-98 information, such as like, dip switches and soft switches and all sorts of interesting information if you're interested in it. This site here has a page specifically about this memory board, and it's the reason why I bought it, because I knew it would work, or at least I'm pretty sure it will work. So it goes on over the different methods of memory expansion in DOS past conventional memory and blah blah blah. What we got to do is find this part right here, which shows all the dip switch information here. And right now, it has two different operating modes, one for filling out the rest of conventional memory, and another one for configuring for when you have more than conventional memory on your motherboard. But right now, obviously, we have 384K, and that's where we want our start point to be for mapping the memory on this board here. This seems to be already set to that same setup, so everything's on except for 6 and 8. So if I shove this in, it should give me 640K of RAM almost immediately. I kind of enjoy the idea of C-bus boards, mainly because, well, I don't have to take the computer apart to, insert them. So long as you get it in the rail correctly. So here we go with the BM1000 board. No complaints yet. We are running at 10 megahertz. Check that out. So this does work. So you can use a BM1000, obviously. It's designed to fill out your 640K. I don't have the software or really the care to use the bank memory because, well, shoot, I don't know how. And I don't think I have any software. I'm not going to be using any text editors or anything fancy like that on this computer. So what we're going to do now is try to run Puyo Puyo with it. Seems to be working. It would have thrown an error, or a memory error if it had failed by now. Let's try and start up a game, see if it has any sort of issues. Of course, this computer runs Puyo Puyo a little slow. It definitely will not run Puyo Puyo 2. Oh yeah, did I say that this was a 26K board inside this computer, or an internally installed 26K board? It's actually more of a 26 board. There's a difference between the 26 and the 26K soundboards because the 26K was designed for the VX and faster. Apparently the original 26 did not like faster CPUs. Also forgive my horrible gameplay, I'm not good at this game at all. Of course, it won't give you any bonus because I don't think the game runs fast enough for you to complete the level fast enough, but hey, that's just my excuse. Scary. So Popful Mail seems to be working just fine. Of course, I'm not sure if this one needs 640K or not. It might. It is a pretty late game for this machine. And one last game is one that I know will show graphical corruption if there's a missing memory, which there obviously isn't at this point. So everything looks fine here. I think with this computer you can actually switch the speed switch while the computer is running down to 8 megahertz and it won't crash, but if you switch it back up to 10 it will. Just for shits and giggles, let's try that real quick. I want to see how slow this game runs in 8. Oh, it's hard to switch. Nope, it just hangs. It didn't like that at all. So it does turn out that the BM1000 is a good board to go for if you have a UV, or I mean a 9801UV2 specifically, not the UV21 or 11, because those come with standard 640K. Or if you have a VM of some sort that does not have 640K in it, like VM machines come in 384K also, then this would be a good board to have. I'm not entirely sure about the older models, like the M and the F series, but that might work there too, but something like that might want something more like this, even though this particular board did not play well with my computer. So next I'm going to try and get something like one of these going here. This one right here is the one that came with this computer originally. This one's the one that I bought along with it. This is 4 megabytes, but as you can see by the board itself, compared to this one, it's quite a bit newer. It has less through-hole circuitry and stuff. This one's a lot older. This probably is more like the kind of hardware you would see made around when the UV was out and the VX and DA or whatever the heck the 386 model is. This is probably more around that sort of era's hardware. Although I do wonder what these connectors are. I'm not sure if those are supposed to be for additional floppy disks or what. That's kind of weird, but it is a multifunction type board, so there's something going on there that I'm not entirely sure about. So unfortunately, it seems, according to that same website, that these are not designed to fill out conventional memory. They are only to provide additional memory on top of that for, EMS. But I'm not sure. It says in order to set the settings down here, you would have to have the software called malware, And Buffalo used to be called Melco. That's just the company name. So malware was what you would use to set your memory board. You would open up the software and tell it which kind of configuration you wanted with your EMS board, and it would tell you which dipset switch settings to set, and you would set it. You would insert this into your computer, and everything would be all happy and ready to go. It would edit your auto exec and config.sys files and do all that good stuff. And so apparently this is more useful for, say, Windows or MS-DOS programs rather than self-booting games, since you would need software to run it anyway. But just for shits and giggles, since this is pretty much the end of the video, I'll just shove this in here in the computer and see what it does. Probably nothing, really. I'll probably ignore it. Oh yeah, another thing I never mentioned. You might notice on some C-bus boards, you'll see this little plastic thingy here. And that's actually there to push a button inside your computer. It looks like it's able to flip up and down if you want it to. Oop. Like that. So what that does is that there's a little button inside of later machines that will switch the C-bus operation, I think, from, was it something 16-bit to maybe 20-bit or something like that. I'm not entirely sure what it exactly does, but it will turn up the throughput through the C-bus. It'll widen the bus, I suppose, on CPUs that support that. So let's throw this in here and see what it does. All right, that should be in there. We'll give it a shot, see what it does. Nope, it's not very happy. So I think the beeping is just that the memory switches inside of the computer are set wrong, because it didn't actually find the full 640K of memory that the CMOS settings had stored for it. So obviously we're not going to be getting any 640K on our memory check here, and obviously if we pop in some, pop in the Puyo Puyo, we'll just get a crying elephant. Yep, it does. It says it doesn't have enough memory. So it turns out, if you want to upgrade the memory on your UV or VM without, well, the VM doesn't have any specialized memory upgrades as far as I know. So on the UV, the UV2 specifically, not the UV21 or the UV11, you would want a bank memory. Bank RAM. Oh, that's the wrong board. Hello. So you'd want a bank memory board, sort of like this, probably from either Melco or IOSys. This one specifically being the BM1000, but this would work for expanding or filling out the main or conventional memory. So that was just my little experiment of testing all my RAM boards to see what can fill up the conventional memory. And it turns out if you want to fill your conventional memory, the best way to do so would be just to get a bank memory board.